All right, day 2 of section 7, talking more about vectors, and this time we're going to talk about bearing. All right, so bearing is for navigation, and here's what you got to know. If you remember, if this was a compass heading, then this would be north, and this would be south, and this is west and east. Now, bearing using for navigation is measured differently from the rest of trig. Trig, what you're used to is using the positive x-axis as 0 degrees and then going counterclockwise around the circle. But for navigation, which should make sense to you if you think about it, that for navigation they were using compasses, right? And they could see north, right? So north is actually where we're going to start. That's going to be 0 degrees, and it'll be measured clockwise. So completely different from the rest of trig. So that means that going due east, directly east, is 90 degrees. If you're going south, that would be 180 degrees. And coming around here to west will be 270 degrees. And then you would come back up to north being at 0 degrees, or 360 degrees too. But anyway, so measuring angles. How do you measure angles with bearing? Yeah, it's clockwise from the north. And that's for bearing and navigation, versus rather than, we'll write that, rather than counterclockwise from the positive x-axis, which is how the rest of trig is angles are measured, right? So when it's bearing, you're going to start from the north and you're going to go clockwise instead of starting with the positive x-axis and going counterclockwise. Much different with bearing. Let's do an example. An object moves 90 meters due south with a bearing. That means the bearing is 180 degrees if you're going due south. And then it turns and moves 40 more meters along a bearing of 250 degrees. We're going to find the resultant of these two displacement vectors. So we're going to draw a picture. I'm going to draw a north, south, east, west, and we're going to start off going south. So I'm going to draw it like this. So there's my north, south, east, west, right? This is north. And it says that you're starting off due south, right? So you're going to use the origin as your starting point. That's where you're going to start. Always start at the origin. And if you're moving due south, well then, let's use a different color. I'm going to go start here and I'm going to move directly straight down. So the object moved straight down due south with a bearing of 180 degrees, and it went 90 meters. So 90 meters is the length of that vector. 90 will be the length of this vector. And then it says it turns and it moves 40 more meters along a bearing of 250 degrees. So what you do then is you're going to, it went to there, it's now at this point right there. So what you'll do is you'll draw a new north, south, east, west, direction thingy from there. And we're going to go with a bearing of 250 degrees, which means from that point, you're going to go and you're going to go around. This would be 90, 180. If I went all the way to here, it'd be 270. I want to stop short of that. I'm going to go to like right there. This will be 250 degrees. And we're going to go a distance of 40. So I'm going to draw another vector going up like that. And there's 40 is the length of that vector. and they want you to find the resultant of the two displacement vectors. So what the heck does that mean? What does resultant mean? Resultant means that they want you to find the magnitude and the bearing of, I'll use this color, this guy here. Because you started here, vector, the first vector was going straight down. We put a new vector on top of that, so tail to head. This is your new resultant vector. I'll call it R. There's R. That's what we want to find. And we want to find the magnitude of it and its bearing. All right, so let's start with the magnitude. Its magnitude, well, I've got this vector and I've got this vector. If I can just find this angle inside here, make it green. Can I find what this angle is inside this triangle right there? And if I can, then I've got a sassy triangle, side, angle, side. Well, if I know that from the top here to here is 250, if I went all the way around, it would be 360. So 360 minus 250 gives you 110 degrees. Since if you had gone all the way around, it would bring you to 360, but we just want right there. All right, so that means that the magnitude, well, the magnitude is going to be the absolute value of this vector R, right? And it's a sassy one, so we can use law of cosines, which means it would be R squared equals 90 squared plus 40 squared minus 2 times 90 times 40 times the cosine of the angle opposite R, which is 110 degrees. But it was, remember, law of cosines was this guy squared, and then I want to take the square root of both sides. So I'm just going to write it as that this magnitude will be the square root of side squared plus side squared minus 2 times side times the cosine of that angle opposite there. All right, so let's put that in. We got the square root of 90 squared plus 40 squared minus 2 times 90 times 40 times the cosine of 110. I got 110. This magnitude of the resultant vector is about 110.283. I'm going to say 28. This is, they gave me units, so I'm going to say meters since it's an application problem. Now, I have a feeling I'm going to need this, so I'm going to store it. I'm going to store this value because remember, if you start rounding now, if I start plugging in 110.28, my answers are going to keep on getting more and more off, right? So I'm going to store it. So I'm going to hit stow, and I'll just store it under A, hit enter. And now if I pull up A, it'll be this 110.28. All right. Then they also want us to find the bearing. Yes, so bearing. Here's what I want for bearing. What color have I not used yet? I've used them all. I want the bearing for R. Well, remember the bearing is going to be from north, right? And then going clockwise until you reach the resultant vector, like that. You see that? That would be the bearing of this resultant vector. And so, let's find the bearing now. Do you see that the bearing would be from the north to due south is 180 degrees. And then if I can figure out what this angle is on the inside here, let's go with yellow. If I find this top angle right here and add it to 180, then it'll get the bearing for the resultant vector. All right, so I'm going to go ahead and redraw this triangle because it's looking pretty messy, right? I've got straight down, down this way, and then the resultant. Well, I just found what this R is, right? This is my 110.28, but I stored it, so that's the value. I'm going to use my stored A value for that guy. I know this is 110 degrees, I know this is 90. I know this is 40. And I'm trying to find this angle here. I'm going to call it theta. Okay. What I can use, I'm going to use, okay, listen. I'm going to use law of cosines. I realize that you doing this, like, you could use law of sines, but the reason why you could use law of sines is because this is 110 degrees and it's already obtuse. And so law of sines will not have the ambiguous case, if that makes sense. Your problem is that if this angle that you're given is acute, if it's smaller than 90 degrees, we don't know if theta is obtuse or acute, and the ambiguous case would give us two answers, right? So if you just use law of cosines, you're going to always be able to get the correct answer. Using law of sines, you can, as long as that guy is obtuse. So certainly this problem, you could use law of sines, but just in case, I'd rather teach you the way that you're safer just using law of cosines just in case. So I'm going to use law of cosines. I'm trying to find theta. And so the side opposite it would be 40. So 40 squared is equal to side squared plus my stored A, right? Stored A value squared, right? This one is equal to this side squared plus this side squared minus 2 times the 90 times that stored A value times the cosine of theta is what I'm trying to find. All right, so then that means, how do I solve for theta? You'll have the 40 squared. You'll need to subtract the 90 squared. I'm going to subtract that A squared. I'm going to divide it by a negative 2 times 90 times that stored A value. That's what will give me cosine of theta. And then I need to take the inverse cosine of both sides. So that's what I'll end up putting in my calculator. That's going to equal my theta is inverse cosine of that whole thing. All right, so let's put it in. Here we go. Inverse cosine of, I'm going to put parentheses around. You got to let the calculator know this whole thing is the top divided by this whole thing in the bottom. You got to make sure you let the calculator know because it will divide before it subtracts. So I added an extra parenthesis in there. It'll be 40 squared minus 90 squared minus my stored A value, not 1, squared. Yeah, 40 squared minus 90 squared. I stored the magnitude as A, so A squared, and the parenthesis divided by, start a new parenthesis to let it know this whole thing is in the bottom. I got negative 2 times 90 times that stored A value. And 19.9. So theta is about 19.93 degrees. But that's not your bearing. Remember, the bearing was 180 plus that top angle, so plus this. So that means that the bearing will be 180 plus 19.93 degrees, which means that my answer is 199.93 degrees. Be the bearing. And I'm running out of room. There we go. Okay. So that's part A, finding that resultant vector along with the bearing. Now, they also want us to find the bearing from the ending point back to the starting point. So I'm going to redraw this real quick. So I had, here's my north, south, east, west, right? And then my resultant vector looked like this. And what they want is the bearing from this ending point back to the starting point. So what they want is for you to draw a new north, south, east, west. And they want this bearing right there. So from this note, so from here back to the starting point, that will be your bearing. Yeah. All right. So, how am I going to do that? Well, what do I know? I know that I know this angle right here. What color? Let's go with pink. I know that this angle right here we just found was the 19.93. Yeah, I knew that one was that. And do you remember that two parallel lines cut by a transversal, that alternate interior angles are congruent, that this angle and these angles, alternate interior angles are congruent, right? Well, do you see it? Two parallel lines cut by this transversal. If this is 19.93, then so is this one. And so your answer is just bearing for part B from the ending point to the starting point is just 19.93 degrees. And that's because of alternate interior angles are congruent. And so these two north-south lines are parallel lines. The resultant vector is your transversal. And if that's 19.93, then so is that one. Fantabulous, right? Not too bad. I know bearing is always a bear to deal with. I get it. It's most students don't like it too much, but all right. I hope you all are having a fabulous day.